Welcome everybody. Today we've got us a fun gate project. The customer had a few gates up here for a series of years. I don't know how long how they lasted, but this spring with the wind and whatnot, the gates blew off the hinges, broke, and there's a couple of reasons why this failed, and I wanted to point it out to everybody and show you kind of the reasonings why behind it, and explain the process of what we're going to do to get some new gates on for the customer here. So the first couple things is the way that the hinges were welded on the square tubing. You can tell here where the plate that they welded to the hinge didn't have a whole lot of fusion. Okay, that's a typical short circuit MIG lack of fusion that causes a lot of failures. And so what happened over time with these gates getting beat by the wind forward and back, they just eventually started to tear off of these side plates that they had welded on the side of these gates here. So right here on the edge of the gate, you can see that the fusion level wasn't super deep, and it was just able to eventually work its way completely off of the gate. So the welding of the plate to the gate wasn't done as proper as it could have been, and so that's what eventually made the gates fail. But another thing that didn't help was the way that the gates were latched. They didn't have an anchoring point into the ground, and so the gates, when they were latched, they had a little bit of room to move forward and back with the wind. And the way these gates were with these panels, they were just these big wind catchers, and you might be able to hear the wind right now as the wind kind of comes through this customer's yard. And I watched these gates just forward and back with the wind, and it just slowly worked its way off of them hinges. And so our new gate design, we're going to try to come up with a design that gives the customer a little bit of privacy, but allows for the wind to blow through the gate, so the gates aren't kind of acting as a parachute and taking that wind and taking that abuse. Another thing that we're going to do is we're going to anchor the gate somehow with a latch into the concrete here below, so the gates are a little bit more sturdy, and that'll help as well. Another thing that we noticed on these gates that the customer had prior to us is this swelling and this bulge of this square tube. If you could see, this used to be a square tube, and it's fairly round now, almost perfectly round here in the middle. And what this comes from is not having proper ventilation in your square tubing. So what happens when you weld all this tubing together is you could trap air and moisture inside of the tube. And over time, through the different weather conditions, whether it's heat or cold, if it's heat, air expands when it gets heated up, and it contracts when it gets cold. And condensation builds up inside of these tubes, which is moisture, which freezes in the winter. So no matter what time of year it is, these tubes were getting strained internally with pressure. And that's why this tube eventually swole and actually split here. You actually see where this square tubing became round and actually bulged and cracked through. And so that's a good example of why it's good to create vent holes in the bottom of your project, gates, handrail, things like that, to where moisture can work its way out and the internal part of those members cannot pressurize. So what I'm going to do is I'm going to pull some measurements so I can go back to the shop, do some CAD designing, and get these blueprints drawn up for the shop so we can put them in the production schedule and get them pushed right through. So the way that they have mounted the previous gates actually did a fairly good job. I'll show you here. They've got a pretty nice thick plate here with 4 heavy-duty bolts getting anchored into this cinder block that's filled with concrete. So I'm actually going to leave this assembly, but what I'm going to do is cut this old hinge off and clean up this material, and we will weld our new hinges onto their existing mounts. That'll save money for the customer. This is done in a good way, so it'll be nice and structurally sound. We can cut off those old bullet hinges and weld our new ones on and go from there. So what I'm going to do is get measurements from the bottom of the pillars and from the top of the pillars and see how level these pillars are, to see how our gates are going to hang. They also have a slight twist to them they're not sitting perfectly parallel with each other. They're kind of flared out. So I'm going to get a measurement from this inside corner from pillar to pillar and this outside corner pillar to pillar. And that will allow me to draw these pillars in my CAD program in the position that they're turned, to make sure that the way we mount these gates and the way I design them is perfect for the way they need to hang on these pillars. So we'll grab some measurements and we'll meet you back at the office, and we'll go over some CAD design and show you how I go through designing these gates, and we'll go from there.
All right, welcome back. We finally got our gate design finalized. This is an exciting time for me to show you guys kind of the workflow that I like to have in my production shop that we have found to be really productive. So me or my project manager will run out, get dimensions, figure out what the project needs, and then we have our own in-house design team at the time. Right now it's just me trying to keep up with everything, but having in-house CAD design makes production way faster. It eliminates a lot of thinking for the welders. They kind of get in a production mode, and we figure out problems or issues with the projects before any material money is wasted. It's a good opportunity for us to show the customer what the end product's going to look like, and get the buy-in from them. And so that's exactly where we're at in this project right now. Let me show you how our gate design turned out. So right here I have the specs for one gate. There's going to be two gates that complete the project, but we're about 88 inches wide, 65.5 inches tall. And we drew this awesome design for this centerpiece. We're going to cut that out of steel plate on our plasma cutter. This design kind of gives a unique look to it. It's kind of fancy, but what I really like is there's a lot of different geometry. So when you're walking past the gate or driving past this customer's house, there's going to be so much geometry there with the different angles and stuff. It's going to be hard to really see through the gate if someone is driving past the house. And it just gives it a unique look. And then here to the side, in this drawing, it's kind of hard to tell. We'll transfer over here. I've got these side panels that we'll be cutting out and breaking to this specific bend spec, and that's where we'll be putting these into the side. And I've kind of got that angled to where the way I believe the wind is going to be coming around that house and up that driveway. That's an opportunity for wind to get through the gate and not be beating the gate up with a bunch of wind vibrating it and keeping pressure on it. So that's why we ended up with this design. The customer's really happy. I was able to spit out a nice material list for our metal processing team. They have got everything cut out for the gate, and it is waiting for production time with the welders. I'll take you up to the shop and show you a little bit of the cut pieces and show you a little bit of the process inside the shop. All right, come on out to the shop, show you what's going on. It's a beautiful sunny spring day, Thursday afternoon here in Utah. I got my welders working 410s right now. Most of them have gone home for the day, but it's basically their Friday afternoon. Spring's out, snow's melted, everyone's excited to get out, so it's a kind of a nice quiet day to do a little bit of recording. Let me show you what we got going on. So I'm going to take you clear over to our metal processing bay and show you where these gates have been getting processed. So this kind of shows you the full process. So this area here is our metal processing bay. This is where we got a majority of our equipment. So I have individuals that are running a schedule about 2 to 3 weeks ahead of the welders, prepping material, cutting it out, cleaning it, making sure it's ready for the welders. That way when the welders are ready, it just hits their plate. They got the blueprint. It's like putting together a puzzle, and production goes twice as fast. So we got the gate cut out over here. You can kind of start to see the resemblance. We got the two center pieces cut out because we're doing two gates.
We got our panel pieces out of 14 gauge there in the middle, and then we're working with 2-inch square tubing about 1/8 thick. So they've got it all processed and clean, ready for the welders. And once the welders have an opening in their schedule, we'll scoot it over to the welding bays and get it into production.
Thank you for watching. This project turned out awesome. We were able to enable some of the younger generation of welders that we had coming through the shop. This was a perfect project for them to practice some of their fabrication skills. We like the way the project turned out. I'm proud of the work that my guys did on this project. The customer's wanting a natural rust finish, so we just left all the material at mill finish and just going to let it naturally rust. Thanks for watching.